Chemical reactions. Well, everybody knows what a chemical reaction is. Also, we know this at a chemical change. When you have a reaction between substances and they get new substances that are the products. The evidence is that you are in front of a chemical change. How do you know? Well, if there is a color change, if there is a gas production, if there is a precipitate that is produced, if there is a change in energy, so you touch the vessel and you feel it hot or cold, this change of energy that can be heat, light, or electricity is also a demonstration that we are in front of a chemical reaction. The odor change also is a sample of chemical reaction. Here we have one example, the formation of water from hydrogen and oxygen. Look at this. We have 2 molecules of hydrogen and 1 molecule of oxygen, and they yield 2 water molecules. The reactants are hydrogen and oxygen, and the product, well, in this case, the product is water. We produce 2 water molecules. As I told you, this arrow means yield. And the coefficients that you can see in the front represent the number of chemical formulas. In this case, 2 molecules of hydrogen. Here, 2 molecules of water. And here, you don't write the 1, but you know there is 1 molecule of dioxygen. The subscripts represent the atoms that are in the formula, in the chemical formula. Well, the principle of the matter cannot be destroyed or create is the one that helps up to balance a chemical equation. For example, here you see that potassium, and look, into parentheses I write S because it's a solid. Water is a liquid. Hydrogen is a gas. And this potassium hydroxide is in aqueous solution. Then these letters that I put into parentheses represent the state of a system. There are a lot of different chemical reactions in the real life: cooking, roasting, combustion, photosynthesis, digestion, fermentation. In all the cases, we are in front of chemical reaction. Let's begin by balancing the chemical equation, taking into account the principle that says that matter cannot be created or destroyed. Atoms cannot be created or destroyed. So, let's begin by here. The first part, we are going to balance the chemical equation where hydrogen combines with oxygen and produce water. Well, the first thing that you have to do is to count the atoms in the reactants and the atoms in the products. In this case, we have 2 atoms of hydrogen in the reactants and 2 hydrogen atoms in the products. That's fine. But here you have in the reactants 2 atoms of oxygen and only 1 in the products. Then, as there is a difference of atoms, we say that this equation is not balanced. Second step, well, I'm going to balance by adding a 2 in front of the water molecule. Now I have 2 hydrogen and 2 oxygen in the reactants and 4 hydrogen and 2 oxygen in the products. Now hydrogen is not balanced. What we can do then? We can add a 2 in front of the hydrogen, and now we have 4 hydrogen in the reactant, 2 oxygen in the reactant, 4 hydrogen in the product. 2 times 2 is 4, and 2 times 1 2 oxygen. And as you can see, the number of atoms in the reactants and the products is the same, and we say that the equation is now balanced. Well, you have to confirm that the atoms are the same in both sides in order to say that the equation is balanced. And the other thing that you have to confirm coefficients are in the simple whole number ratio. What does it mean? That maybe you can have here a 4, a 2, and let me type in such a way that you understand. For example, you can have 4 molecules of hydrogen, 2 molecules of dioxygen, and 4 molecules of water. But as you can see here, the number of atoms will be balanced. But this is not the balanced equation. Why? Because you can cancel here by 2, by 1, and by 2, and you get what? The smallest possible whole numbers. Okay? This is an important step. Well, here we have an equation of combustion. This compound is methane plus oxygen, produce carbon dioxide and water. All the combustion reactions will produce CO2 and water. Well, you will count the number of carbon, hydrogen, and oxygen. You can see that hydrogen is not balanced, oxygen is not balanced. Then what we do in this case? We add a 2 in front of the water molecule, and now you have 1 carbon, 4 hydrogen. Oh, but the oxygen is not balanced. Then what we do in this case? We put a 2 in front of the oxygen, and now look, 1 carbon, 4 hydrogen, 4 oxygen, and this is the balanced equation. You cannot cancel these coefficients to make simple ones. They are the most simple possible ones. Oh, sorry. Let me go now to well, this is a synthesis reaction. When you combine 2 elements or 2 compounds and make only one, this is what we call combination reaction or synthesis reaction. In this case, you have 1 compound and you divide into simple substances or compounds. In this case is what we call decomposition. Single displacement reaction is when, for example, A displaces B and now B goes along. This is a single or simple displacement reaction. Double displacement is when A takes the position of C and C takes the position of A. This is a double displacement reaction. And here you have an example. You can stop the video at any time and see the example. It's good for you if you write this example in your notebook. Combustion reaction is every time you have a compound that burns in presence of oxygen and produce carbon dioxide and water. This is a combustion reaction. This is what we call a redox reaction, when the atoms are in the single state that they are supposed to have here as 0. This is the oxidation number. The same thing here with copper, because they are alone. As you can see, zinc in this reaction goes up. The oxidation number here is +2. And here, copper from +2 goes to 0. Then this zinc is increasing the oxidation number, but copper is reducing the oxidation number. That's what we call oxidation reduction reaction. An acid-basic reaction is when you have an acid and a base, and we get a salt. This is a salt because it's made of a cation and an ion, and they are combined by an ionic bond. And at the same time, we have always as product water in a neutralization reaction. It's a reaction between an acid and a base. Well, at normal temperature, some metals combines with oxygen to produce oxides. Sometimes only produce the oxide when they are heated by fire. For example, magnesium combines with oxygen when it is fire, when it is heated, and produce the oxide. The same thing with oxygen. But oxygen generally produces a reaction and the product of this reaction, the iron 3 oxide, is what we call rust. Well, here we have a combination, a synthesis reaction, because two simple substances make any one. You can stop the video and balance this equation. Here you have a decomposition reaction. Please stop the video and balance this equation. Here you have a single displacement, zinc takes the position of hydrogen, and hydrogen goes along. Please stop the video and balance this equation. And here you have a double displacement. Copper occupies the place of sodium, and sodium takes the position of silver in the products. This is a double displacement reaction. Combustion, as I told you, a compound combines with oxygen to produce carbon dioxide and water. Here you have a neutralization reaction between sulfuric acid and sodium hydroxide that produce the salt, sodium sulfate, and always water. Well, that's all. I hope that you understand, and see you soon.